Hey people, so I've decided I want to try doing some product teardowns along with all my other videos because as a design engineer I'm curious to know how things are made and why. I want to document not only for my own learning, but I hope this video teaches you something new about the products we use day to day. I'm going to explain some of the design features of this generic fitness tracker and open up the insides to see what's going on and how it's constructed. So we'll get straight into the features of the tracker, starting with one single touch sensitive button to navigate through the various inbuilt apps, from a clock to step counter, heartbeat tracker, walking, running and cycling tracking apps. There's also battery and signal status symbols on the upper section of the display. The tracker is IP65 rated, which means the highest protection against dust, which is 6, and it resists low pressure jets of water, which is rated number 5, such as a shower. In theory, it wouldn't last when you go swimming or submerge, though I've taken this tracker to the beach and gone swimming with it and it did totally fine. The strap has a simple and intuitive buckle design, easy enough to adjust, allows adjustments for wrist circumferences ranging from 140mm to 220mm. These straps are removable from the main body, which I thought was quite a novel idea. This reveals the USB charging male plug on one side of the body. I like how easy this makes the charging process, which means no cables are needed. Okay, so looking at the dimensions, measuring at 19.5mm wide. This is 4mm wider than Fitbit Ultra HR, 41mm long, 10mm high, and about 11.3mm high overall from the sensor. The band is 50mm wide with 14 slots, 6mm pitch for varied adjustments. Okay, so starting with removing this double-sided spring pin in the buckle. The buckle seems to be made of a sturdy yet light aluminium alloy. The strap is a flexible plastic. I think it's polyurethane with a shore hardness of roughly 80 A and could have been compression or injection molded. The main pod assembly is split into two pieces: upper enclosure, which is the screen cover, the tinted black piece, and the lower enclosure, which we'll call the body, the silver painted piece, which you can see some of the paint has peeled off. Both parts are made of plastic. The body potentially could be a fire resistant black ABS plastic and is definitely injection molded and painted over in a sparkle grey on the visible exterior to give it a shiny metal appearance. The screen is a translucent ABS or polycarbonate piece with a black tint, also injection molded. So trying to get the screen part off the body took me like 20 minutes, so we'll fast forward this. To make this body completely sealed and IP65 rated, you'll see that the cover and the body enclosures basically mesh with one another with a fairly tight tolerance, and then they're literally glued together around the edge with the intention that the product will never be opened again. Pretty cheap and nasty from a design perspective, but it works to achieve that IP rating. Okay, so we are in now. First thing to note is these contact plates on the other side of the screen, which connect with the PCB on the top and bottom. The lower pad is for the touch sensor, and the upper I think is for the connection to the vibration motor, but I'm not completely sure. If anyone knows, please do comment. So we can see that the touch sensitive button is like a compressible switch. So a light tap on the external of the screen connects this switch with the contact pad on the screen we just saw. We can see how the LED screen is attached with its flexi solder connector and taped into place. Two self-tapping screws hold down the main PCB to the lower enclosure. Self-tapping screws are ideal for assembly and manufacture because it means there is no need for threaded inserts in the mold, which saves money. I would say self-taps are useful if you don't intend to maintain the product, essentially, because the threads can wear out over time. Okay, so we can see that the PCB is wired to the battery sitting directly underneath. We can also see there are two pogo pin spring connectors which touch the two outer contact pads for the USB power connection. And then the lower PCB, which has the heart rate sensor, is connected to the main PCB via a small ribbon connection. The main PCB has an accelerometer, which allows the device to measure movement, specifically counting footsteps for the step counter or when you run. The accelerometer is able to achieve this because it can detect fractional changes in the X, Y or Z axes. Next, we're going to pop this guy out. This is a pager or vibration motor. It's used for haptic feedback when the touch button is tapped or when the alarm clock goes off. It works by rotating the eccentric mass counterweight on the shaft rapidly to create the effect of the whole device vibrating. The heart rate sensor is on this PCB. Optical heart rate monitors are the most common pulse sensors in wearables. This uses two small LEDs on each side, about 7mm apart, with a single optical photodiode sensor in the center. Both LEDs flash a green light simultaneously, hundreds of times per second at your skin. That light is then either reflected back to the sensor by no pulse in your vein or absorbed by blood flow. The fluctuations in light level can then be translated by the sensor into a heart rate. The green light color is purposely chosen because our blood absorbs this wavelength most effectively, which produces the most accurate readings. This process of using light to measure blood flow is called photoplethysmography, or PPG. The last thing I have to note is the USB power connection. This would have been manufactured using insert molding, where the 4 gold plated copper contact plates would have been placed in the mold tool prior to the plastic being injected. This is to ensure the IP65 rated seal of the overall product. Cool, so that's all I have to show on this. Let me know, guys, if you have any questions and if this was any help to you. If there is any information you think was incorrect, also please let me know. Cheers, guys, and I hope you have a good one.